last line. What is that last line? Because here we only have two. What would that last line be called? That is what we call resultant. Resultant of a vector is that single vector that will have the same magnitude and direction as other vectors coming together, right? So it will have the same magnitude and direction. It is that single force. What we mean by that is, assuming we have a tap here, assuming this is a tap, then a knob here, then water is rushing out. Yeah, this is a tap. We say a tap. Now, if you notice, if we turn this tap, water will rush out. Why? In a normal sense, if this was not here, right, then how do we force this water out? We have here. We'll have to use our strength, push it up, or use two hands to turn it. But the modern tap, in a modern tap, we need to find, for us to make it with ease, we'll find that single force that if we just give a turn, it's gonna start rushing out. That single force is in the middle here. That is why the tap is constructed like this. So this single force here is called the resultant. So it has the same magnitude and direction as these two. So you combine the two together to form it. Alright, so now to project the resultant vector using this triangular rule, the tail of the is also a vector, so it will have a tail and a head. So the tail of the resultant will coincide with the tail of the first vector, and then the head will coincide with the head of the second vector. Then we can call this R for resultant. So basically, this is how we represent it in a triangular form. So where this is the first vector, the second vector, and then this is a resultant. So how do we also, I said parallelogram, how do we also represent this vector in a parallelogram? Easy. Unlike the triangular method that will tell me that this guy will come here, the parallelogram, you draw the vector exactly how it's inclined. Then you will trace to complete a parallelogram. Now a parallelogram is here is a quadrilateral which the two parallel sides are equal. These two are this one is parallel to this and it's equal to this. This is parallel to this and it's equal to this. So therefore, if I have 5 here, that means I have 5 here. If I have 6 here, that means I have 6 here. Alright, so how do we use this to represent vector? We need to find that resultant, that single force that will have the same magnitude and direction as these two. So that instead of us to use the two, we just have a single force that will have the same power as though we were using these two. So this is what happens. There is a parallelogram law states that if two vectors which has a magnitude and direction is represented by the two sides, by the sides of a parallelogram, right, the resultant, which has the same magnitude and direction as the two other, is drawn such a way that the tail coincides with the point of collision between these two vectors and one outward. So therefore, this is the resultant. It is not here. The resultant cannot be here. This is wrong, because this is only the image, the fake side. This is the real side. So the resultant must start from here. So that is basically what it is. So I'm going to give you a minute to look deep into it. Alright, welcome back. Okay, so for the Cartesian, we are not going to handle the Cartesian now until later in the video. So for now, we are going to work this through easily. Let's move forward. Now, so here we have triangle method. That's what we want to focus on. Before we use the triangle method, I'm going to brief you a little bit on the rules. So rules to use First, you need to understand this concept that total angle in a triangle, total angle in triangle equals 180 degrees. Grade 2 mathematics. 2. That the sum of angle in a right angle makes up 90 degrees. So if I call this angle A, angle B, now A plus B is equal to 90 degrees. This you need to have this. Put this in your toolbox because we need it. 3. That angle on a straight line, we have A here, we have B here. Angle on a straight line is equal to 180 degrees. So or they are complementary. Supplementary, sorry, this is complementary, this is supplementary. Okay. 3, for two parallel lines, then we have if an angle A, B, C, and D, and then we have E, F, G, and H. Then, for us to get the line properties from here, we'll notice that A, from our grade 2 math, A degree is equal to E degree, right? Angle A is equal to angle E, right? Angle D is equal to angle G, angle B is equal to angle F, angle C is equal to angle H. This is what we call corresponding angle. Then we also see that angle E is equal to angle C and angle D is equal to angle F. We call this alternate angle. So basically, this is what it entails. Easy, right? Okay. Then the next tool you need to add to your toolbox. The next tool you need to add to the toolbox is what we call cosine rule. So if we have a triangle like this, we call it like a triangle. I will teach you how to name triangle or label triangle. I could use any letter, but I will use capital for the vertex. A vertex, all these points of intersection is called a vertex. So A, B, C. I use capital letter. So this is basically triangle ABC, right? Or ACB or BCA, anyhow, depending on your reference. But of course, in the English alphabet, yeah, ABC. So this side that is opposite to this angle here automatically becomes small c. This side here becomes small b, and this side here becomes small letter a. So this is how you name triangle. So this side that's facing this will take the small letter for this alphabet. That's a trick. That's for the English students. Yeah, if you are in Greeks, or if you write in Greeks, if you write in Latin, okay, anyhow you language Korea, you can actually draw a triangle and give me your own label, and I would love to see. Drop in a comment. Okay, so how do we solve cosine rule? Cosine rule is used for this. We need to understand the SAS. With 3 mathematics, you can remember that this is side, angle, side. How does it work? If I'm looking for this side, C, then I'll use this other side and the angle in between the side. If I'm looking for B, I'll use this angle and this side